Hello everyone, in this video we are going to discuss about the concepts related to the Gantry Girder part 1.
Okay, so the next topic in our discussion is Gantry Girder. So far we have discussed about plate girder. So plate girder is nothing but a beam which is used as a bridge, and we know the some other conditions also. For example, if a rolled steel section is unable to withstand a applied load, then we go for built up beam. And again, if built up beam is also unable to withstand a applied load, then we go for plate girder. That too, whenever the span is large and loads are heavy, then we go for plate girder. So mainly we use plate girder in bridges. Clear? So now let us see the gantry girder, where we are going to use. No doubt, girder is nothing but beam. So girder is a synonym for beam. So previously we have discussed about plate girder. There is a it is made with the plate, that is why it is called as plate girder. Now it is called as gantry girder. So let us see where it is used and what is its importance. Clear? So if you observe about gantry girder, it is an laterally unsupported beam used in industrial buildings. For carrying heavy loads. Like heavy machinery, equipments, etc. Heavy machinery, equipment, etc. So this is what gantry girder. So obviously gantry girder is also in a beam. But if you see here in the first line itself, we have clearly written that laterally unsupported beam. We know what is meant by laterally supported and laterally unsupported in the beginning of the design of the beam itself, or you can say exactly in the beginning of the design strength, okay, design bending strength of the beam. So there itself we have discussed in detail what is meant by laterally supported beam and laterally unsupported beam. So now the gantry girder comes under the category of laterally unsupported beam, and this beam is used in industrial building for carrying heavy loads like heavy machinery and equipments. Clear? So that is the gantry girder. Now let us see the diagrammatic presentation of this gantry girder. Clear? So which is more important to understand. If you understand the diagrammatic representation, so then rest everything is very easy. And that too, coming to this gantry girder also, the provisions. Okay, there exist some provisions given in the code, so which are more important from the exam point of view. Clear? So first we'll see the diagram, and after that we'll see the type of loads it is subjected to and its function. Of course we have seen its function, and then we go for the dealing the provisions. Okay. So this is the built up column. So this is built up column. So here we have provided the built up column by using lacing. Okay, built up column. So now we are going to place our gantry girder on this built up column. We know what is meant by built up column and techniques used for building a column. So we have discussed all those in detail, that is lacing and back knee. Clear? So on this built up column, we are going to place our gantry girder. Now let us see how it is. So this is our gantry girder. So gantry girder is also nothing but an I section. Okay, gantry girder is also nothing but an I section. So this is gantry girder. Okay, so on the top of the gantry girder, we are going to provide a channel like this. So this is the channel. Clear? This is the channel we have provided on the top of the gantry girder, I section. So obviously gantry girder is nothing but I section. So this is the channel. Clear? So on the top of this channel, we are going to place a rail. So this is the rail. This is the rail. So on the top of the rail, there exists a wheel. Okay, there exists a two wheels. So on this wheel, we are going to place a truss. Okay, bridge truss or crane truss. So like this. So the length continues. So this is the truss or crane bridge. Clear? So this is the truss bridge. So this is crane or truss bridge. So now similar type of arrangement, that is built up column. On that built up column, we are going to place a gantry girder, and the compression flange of the gantry girder is reinforced by a channel, by placing a channel, and then rail. On the rail there exist two wheels. Now these wheels are going to support this crane truss or crane or truss bridge, and the same similar setup will also exist on this side. Agree? So now there exist two trusses. Clear? This is one truss, and next to that there exists one more truss. On this truss, okay, on this truss there exists a trolley or crab like this. So this is trolley or crab. Okay, so if you observe any railway bridge made up of truss, which is called as truss girder. So we know that train will move on that girder. So then obviously there exist two trusses on either side. In between train will move. In the same way, here one truss and the back of this truss there exists one more truss. Okay, the two trusses. On this truss, this trolley or crab will move. Okay, trolley or crab will move in the direction, you can say the lateral direction. So this is the I section. The length of the gantry girder is perpendicular to the board. Okay, try to imagine it. So length of the gantry girder is perpendicular to the board. Now these crab or trolley will move on the truss. Okay, move on the truss in this direction. It means you can say that is the lateral direction of the gantry girder I section, and here these truss is placed on the two gantry girder on either side. Here one gantry girder and here one gantry girder. Now this truss will move in the perpendicular direction of the board. It means both the truss and crab both will move. Agree? Both these truss and crab will move. So now these truss will move in the longitudinal direction or length direction of the gantry girder, and this trolley will move in the lateral direction or transverse direction of the gantry girder. Agree? This is the setup. Clear? These are the parts, and the purpose of providing the channel is, as we discussed in the beginning itself, the gantry girder is a laterally unsupported beam. So even though it is a laterally unsupported beam, to increase its lateral stability, we are going to provide channel. So upon providing the channel, the moment of inertia of these gantry girder or I section will increase about by way. Do you agree or not? So if we take gantry girder, so this is the x axis and this is y axis, and no doubt that along these x axis moment of inertia is more. So we know that ix is more than iy. So if you place channel like this, then obviously iy will increase. So this is yy, iy will increase. So now main purpose of providing channel is to reinforce the compression flange of the gantry girder in lateral buckling. Clear? Compression flange of gantry girder. Gantry girder is reinforced. By providing a channel on its top to increase lateral stability. So take it down. So this is a diagram of gantry girder. Obviously, here this is the gantry girder which is going to take the loads. So first you take the diagram, later I'll explain how many types of loads that are coming onto this gantry girder. So first take the diagram. So once again explain the diagram, listen. So this is the built-up column. On the built-up column we have placed the gantry girder I section. Clear? So after placing this I section, we are going to place a channel on the top flange or compression flange to increase the lateral stability or to reinforce it. After that, on this I section we are going to place a rail. So on which there existed two wheels. It means total how many wheels will be there? Total 4 wheels. So 2 here and 2 here. So on those wheels, these bridge or truss bridge or crane bridge will move in the length, or you can say the longitudinal direction of the gantry girder, which is perpendicular to the board. So it means truss will move in this direction. So now these truss bridge or crane bridge will carry the trolley or crab, which will take the loads. Okay, which will take the load. So it will move in the transverse direction of the gantry girder. It means trolley will move in this direction. See here, trolley will move in this direction and the truss will move. So see, truss will move in this direction. Clear? So truss will move in this direction and trolley will move in this direction. If you observe, see here, trolley will move in this direction. It means here the I section is there. So trolley will move in this direction and truss will move in this direction. It means perpendicular to the board. This is the movement. This is the direction of the movement of the truss, and this is the direction of the movement of the crab or trolley. Clear? So first take the diagram clearly. So later we'll see some provisions regarding this. So take the diagram. So if you observe the types of loads on gantry girder, so gantry girder is subjected to three types of loads, or you can say it's subjected to load on all the three axes. What are those loads? Let us see. So first here I am going to write vertical load. So vertical load means in this direction. Okay, this is the direction, vertical load. So the gantry girder is subjected to vertical load due to self weight of this truss bridge, or you can say the crane, and the self weight of the trolley. Okay, self weight of trolley and weight on trolley. Okay, weight on trolley. Self weight of rail. Etc. means self weight of channel, its own self weight. So because of, we can say the dead weight or self weight, the gantry girder is subjected to vertical load. Clear? So vertical load. So this is the one type of load. So take it out. So once I repeat, because of the self weight of this crane bridge and the weight on the trolley and the self weight of the crab and the self weight of the rail and self weight of the channel, self weight of the its own self weight, because of its self weights and the load on the crab, the gantry girder is subjected to load in vertical direction. So this is the vertical direction. Clear? So this is the vertical direction. That is a load. And if you observe, all these self weights are static in nature. Agree or not? So all these self weights are static in nature. So obviously, if you observe the self weight of truss and the self weight of crab and weight on the crab, okay, weight on the crab is transferred to the gantry girder through these wheels. Agree or not? Do you agree or not? So the self weight of crane and the self weight of trolley and the weight on trolley is transferred to the gantry girder through these wheels. So here the wheels are going to provide the reaction to this. Clear or not? So through the wheels only these self weights are transferred into the gantry girder. Clear? So because of this, the gantry girder is subjected to vertical load. Next is lateral load. So lateral load means this is the direction. So this is the lateral direction. So why this gantry girder is subjected to lateral load? Come on, tell me, see the diagram and try to tell. So the gantry girder is subjected to lateral load due to the movement of trolley or crab. Clear? Due to movement of trolley or crab. So because of this movement of trolley or crab, the gantry girder is subjected to lateral load. Next, third, longitudinal load. So longitudinal load is nothing but perpendicular to the board. See, if you observe the three axes, one is perpendicular to the board and one is YY here and one is XX and another is ZZ perpendicular to the board. So on the board, if you show the vertical load is nothing but vertical load axis is YY and the lateral load axis is XX and longitudinal axis is ZZ. So which is perpendicular to the board. Clear? Perpendicular to the board. So because of which the gantry girder is subjected to longitudinal load, or you can say perpendicular to the board. So because of the movement of the truss. Clear? Because of the movement of the truss, these gantry girder is subjected to longitudinal load. Due to movement of crane or truss bridge. So take it out. So now if you observe, out of these three loads, vertical load is static in nature. So mainly vertical load is because of self weight or dead weight. But coming to the lateral load and longitudinal load, they are due to movement of crab and crane respectively. Agree or not? So it means, for example, we taken a small example. For example, I am having a weight of 80 kgs. Clear? So I am staying here. So now obviously the floor which is going to support us is going to take a load of 80 kilonewton, or it has to take a load of 80 kilonewton, but I am running. Okay, I am having a self weight of 80 kg and I am running on this floor. Then, in addition to my self weight, this floor is subjected to some impact or not, because of dynamic nature of the load. Clear or not? It means now my load may not be or you can say it is not 80 kilonewton on the floor. It may increase because of the impact action or movement of myself. Clear or not? In the same way, this self weight of the crane will have some value, which is transferred to the gantry girder through these wheels, and this self weight of the trolley also will have some value, which is transferred to the gantry girder through these wheels. But as they are moving, now the load on the gantry girder is not equal to its static weight or static load. The small example I said, so if I am standing like this, so my weight may be 80 kg, so it is 80 kg, so the load on floor is 80. But if I am running, then the load on floor may not be 80 because of impact or dynamic nature of the load. In the same way also. Clear? So it means, so first we have to calculate, or first we have to find the static load or the self weight of these things, and we have to increase those loads. The reason, because of the movement of these trolley and crane. So how much to be increased? So that is known as impact factor. Now let us see that how much load to be increased. And one more thing you have to remember here. So gantry girder is subjected to these three loads. Out of these three loads, this is static and remaining a dynamic in nature. So now all the three loads should not consider at the same time. It means, see, self weight will act at any cost, no doubt. It means gantry girder is subjected to vertical load at any cost. We should not vary it, or we should not manipulate it. But what we can manage, so either movement of truss, or you can say crane bridge or trolley. So it means we can say that we should not move the trolley and the crane at a time. It means first, if we are moving a crane, then we have to make this crab or trolley rest. So if we are moving this trolley or crab, then we have to keep this truss or crane bridge in rest condition. That is the thing. It means all the three loads should not consider at the same time. It means along with vertical load, either we should take lateral load or longitudinal load, but not both at the same time. As we discussed, this load will act at any cost. We should not do anything. But either we are going to move this or this. It means move the trolley or crane, so that now the gantry girder is subjected to at the same time vertical load plus either lateral load or longitudinal load. That is the thing. So now let us see, because of these dynamic nature of the loads, that is movement of the crane and crab. So how much the loads to be increased? Now let us see that. Clear? That is known as impact factor. So I am going to rub this. So make a note and you write on that point. Along with vertical load, either lateral or longitudinal. Either lateral or longitudinal load is to be considered. Okay, so along with the vertical load, either lateral or longitudinal load is to be considered. Not all the three loads to be considered at a time. Okay, not all the three loads to be considered at a time. Clear? So that is a note. So first you take the note.